Hey, welcome back, everybody. In attendance today, we got Maximus,
Hello.
Celeste, and Marcus. Good. Hey, listen, let's get right into the lesson. And let me go ahead and share the actual smart view of this file. Or no, that's not it. This is it. Good. Okay, listen, I'm excited today because today we're going to actually talk about, oh no, this is not it. Wait a second. Let me share the right screen. Now, today we're going to move into one of the foundational things to do with geometry, and that is three-dimensional figures and cross-sections. Now, let me zoom in because I want to make sure everybody has the benefit of seeing this a little bit better. Let me zoom in a little bit more. And I want to zoom in, so kids, you tell me, is this Zoom good enough for you guys to read?
Yeah. Yep.
Celeste, Max, Marcus, yeah, we're good? Okay, good, because I think I may be able to zoom a little bit more. See if I could do it with my computer. Yeah, because I want to make sure that you kids could see the page and everybody correctly. No, actually, no, that's the maximum zoom, so we'll stay there. All right, good. So, hey, listen, today we're going to learn about volume. Now, volume is fundamentally important in mathematics because other than area, we also have to know how much things fit inside of things. All right, so with that, let's go ahead and start with Celeste. Celeste, why don't you go ahead and read the first vocabulary term, which is polyhedron.
Polyhedron, a three-dimensional figure whose surfaces are blank.
You know what that blank is? Surfaces are polygons.
Polygon.
Okay. Hey, so kids, so what qualifies as a polyhedron?
What?
Well,
What qualifies as a polyhedron?
Figure whose surfaces are polygons.
Yeah, so basically it's trying to say that any 3D shape is a polyhedron.
Well, what about a sphere?
A sphere, a polyhedron? No, it's not a polyhedron. So you're right.
Be quiet, Mark.
Certain ones are not. They have to make polygons. So that's a good question. I like that you brought that up. All right, excellent. Okay, so now let me erase this. And Marcus, go ahead and read the next definition.
Base. The flat blank of a polyhedron.
Okay, so what do you think the blank is?
Side.
Yeah, the flat sides. Okay, so here's a face. You see me highlight this? There's a face. Let me highlight the other one. There's another face. There's another face. Does everybody see the faces? Now, I know that one benefit that you had is that most of you have covered faces before, so you kind of have an idea. And since we have a face in our bodies, then we kind of know it's the forefront of what we have, right? All right, excellent. All right, Max, go ahead and read the next one.
The intersection of two blank of a polyhedron.
So an edge, reread it.
The intersection of two blank of a polyhedron.
Okay, what do you think this is? Hold on. Oh, I just made it bigger. Wait.
Okay, intersection two. Vertex?
Hold on. This is not moving. There you go. Hold on. Wait. Let me lock the screen because it's acting weird.
Uh-oh.
All right, we'll get there right now. We'll fix it. There you go. Okay, so the intersection of two faces. So as a result, here's an edge. You see the two faces that got intersected? Ooh, hold on, I'm making lines. There you go. So there's an edge. So you see the edges? And it kind of points right here too, where the edge is. You see how the purple's pointing out to the line? Where there's the intersection of two faces? All right, excellent. Okay, so now let's go into the next one. Celeste, go ahead and read the next one. What is the next? Read vertex.
Vertex. The blank of the polygon faces in the polyhedron.
Okay, so what do you think this is here? Let me take it out.
Intersection.
So the intersection of the poly faces in a polyhedron. So they intersect. Okay, so here's a vertex right here. Let me make it in red instead. There's The vertex, there's a vertex. Does everybody see where I'm making vertexes?
Yep.
Is this a vertex right here?
No,
Remove those two dots. Why not?
because it's not a pointer and where the two faces go.
Yeah, exactly. They're not, the faces are not intersecting of the polyhedron. Like this, the intersection ends have to be here. All right, excellent. Okay, so now, Marcus, go ahead and read the next one. Read prism.
Prism. A polyhedron with two congruent and parallel blank.
Yes, two congruent and yes, two congruent. Good. So it's important because how do they name a prism? Do you kids know?
I don't know.
By their bases.
Yeah, by the basis. The base is named the, so like in this one, you see how this one is a rectangle here and here? Oops, hold on, that's too big. Let me get it in blue and smaller. Okay, so, ooh, didn't do smaller, give me a second. There we go. Okay, so here, let me try to draw it in. So do you see the space right here? You see the base there? Are those bases congruent?
Yes.
Good. Are they parallel to one another? They're congruent and parallel. Yes. Okay, good. So that's how you know that this is the reason why it has the name rectangular prism. Okay. Now let me go ahead and ask you this. This is a triangular prism, but you see this space right here? You see this other one over here? Are these congruent?
No.
Well, actually, I think they are, but are they parallel though?
No.
No, exactly. So that's the reason why this is a shape of a rectangle, what I highlighted. It's not a base of the prism. Let me undo what I just did and let me draw the true bases. You see the one in green? You see the other one in green? Okay, are these two congruent?
Yes.
Right? Okay, are they parallel?
Yes.
Are they triangles? So
Yes.
as a result, that's how we get the solution that it's a triangular prism. All right, good. Let's move on to the next one. Max, go ahead and read the next one.
A
But
polyhedron.
start with the definition. If you don't hear me say it, you have to say it so in order for everybody to understand.
The definition of a pyramid.
Pyramid. Start with pyramid. So pyramid.
Pyramid. The definition. A polyhedron with one polygon blank and lateral faces that are blank.
Yeah, so we have one polygonal base and lateral faces that are triangles, right? So that's what makes a pyramid. And there's a good illustration, a good solution to that over here. All right, now let's go ahead and go with Celeste. Go ahead and read. Oh, you have a question? What's your question,
What
Celeste?
does lateral mean?
Lateral means the edges. So these, and that's a good question, because I know for you, you probably never heard the word lateral before, but these are all lateral. You see the one I just highlighted? That's lateral. Lateral means basically the side. Like when you look at the sides of, that's in essence what it means. It means sides. Now I'm gonna close up some applications real quick because it looks like I am running this, it's running a little slow and I think it's because of the open applications I have. So hold on a second. Let me close these down and then hopefully it will, everything will run much easier, smoother, and faster. Close this one, close this, okay. And now let's, oh, hold on. No. All right, good. Okay, so now let's continue with Marcus. Marcus, why don't you go ahead and read the next one?
Cylinder.
Yeah, cylinder.
A three-dimensional figure with two congruent blank bases that are parallel.
Yeah, okay, so two congruent,
Circular.
yeah, circular bases, right? So then, and you have a good solution here to the right. All right, so now, Max, go ahead and read cone.
Oh, cone, a three-dimensional figure that has one blank base and a curved lateral face.
So one circular base and a curved lateral face. All right, good. All right, now let's go back up and second, let me bring this back up and have Celeste. All right, Celeste, go ahead and now, ooh,
Sphere.
yeah, but let me try to go back up.
Sphere.
Wait a second, because,
Okay. Wait.
yeah. Oh, no, I moved it. Hold on, let me hit undo. Undo until we get back to the way it was.
Uh-oh.
We're all good. And this is the reason why everything's good. All right, excellent. All right, Celeste, go ahead and read sphere.
Sphere. The set of all points in space that are blank from a given center point.
That are, and here it is, equidistant. Yeah, so, and that's how you know you have a sphere. You have the benefit that they're all going to be the same distance. All
What's
right, so now it just means this. It means the same distance. So just to kind of give you an example, Celeste, the center of a sphere, say it's there. You could draw a line anywhere from that center to the outside, and they're always that line, kind of like a radius. It's going to be the same shape.
Okay.
That's what it's trying to say. So you're going to have the benefit of having the same distance no matter how you draw the line to the outside. Okay. All right, Marcus, go ahead and read the next one. Cube.
A polyhedron in which all 6 faces are blank. Squares.
Yeah, so that's how you know you have a cube. They have to be squares. So as a result, you have a cube. All right, Maximus, go ahead and read the next one, net.
A two-dimensional pattern that you can blink into a three-dimensional figure.
Okay, so you could fold. Now, hey, listen, why do we draw nets? Does anybody know?
To see the 2D form?
Yeah, it's kind of like a 2D form. Also, it's easier to find surface area of a net. Okay, because you know, everything that has volume could also has surface area on the outside. All right, Celeste, go ahead and read the next one, which is cross section.
Cross section. The blank of a solid and a plane.
Okay, so it is
Intersection.
intersection. Yeah, every once in a while they'll throw you this. And let me highlight it here. You see this figure right here? They'll cut a figure and then they'll ask you, okay, what did you just build? So like on this first one right here, let me draw it in green. When this cuts the cylinder, what kind of shape is in there?
A cylinder.
No, actually, it's gonna be like if you took that cylinder and you cut it, like, and you could take a real life cylinder and cut it, you're gonna discover that the shape that's left over is a rectangle. Yes.
Well, that's the
You cut
bottom
it.
side.
No, but that's the thing. You see the cross section, the thing that is that shape that's cutting it?
Mm-hmm.
The intersection of that shape with that cylinder, exactly at that point, makes a rectangle.
Oh.
Okay, so like you see this next one, let me highlight this one. This next one, this one cutting this cone. If you can notice, you see how it makes like a circle on this one? The cross section on this one is gonna be a circle. Okay, so that's what a cross section is. All right, good. All right, now, Marcus, go ahead and I want you to read this definition right here.
The sum of the number of faces F and vertices of a polyhedron is 2 more than the number of its edges, E.
Okay, good. So this is great. Where can you see yourself using this? Does anybody know? Or why is that important, what I just highlighted? Hey, listen, kids, if you knew the number of vertices and faces, or let's say the number of edges and faces, and you wanted to know the number of vertices. Would this equation
okay.
make it easier for you to find it?
Yeah.
Because it's easy to count faces. Sometimes it's easy to count edges. And you wanted to solve for vertices. Is it now possible for you to do it in a much easier, simpler format?
Yes.
Yeah. Now, not only that, but let me ask you this. Is it possible that if you wanted to make sure you had the right number of faces, vertices, and edges, that if you put it into the equation, they all should match? Yeah, so it's a good way to check too. It's a good way to know the solution if you actually have a correct equation. So there's two benefits to knowing that equation. And let's go ahead and go over to our examples and let's use that. So here's, all right, let's go ahead and, Max, go ahead and read the directions on example 1.
For each polyhedron, use Eulers formula.
It's called Eulers formula. And Euler's the one that came up with this formula. So let's go ahead and, so you see how you're given this? What would you do to solve A, Maximus?
Me?
Yeah.
Okay, so we're trying to find faces. So
Yeah, they want
replace
faces.
V with 8 and E with 12.
Good. And then what do you do from there?
You do adding them, so you do 12 plus 2 is 14.
Okay, good. And then what else?
8 divided by 14.
Well, you don't want to divide. Why not?
Oh no,
You want
no,
to subtract.
well, you
Yeah,
minus.
you subtract. Yeah, so guess what the answer is going to be?
6.
Yeah, it should be 6. Exactly. So as a result, that solution 6. All right, so let's do the next one. Lead me through. How do I solve B?
That reminds me of a cube, number A, like the letter A. Isn't
Okay.
the shape a cube?
Is that a cube faces 6? And it may be, actually not necessarily a cube, but it could be a rectangle, a rectangular prism or a cube prism. But let's move on to the next one. So let's say, how'd you do B?
How you would do B? So you would do, well, F plus 9? No.
Well, not F plus 9, because see, in this case, faces is 9, right? So we'll have F, well, actually, I'll have 9 plus 14. You see that? And we're trying to find edges this time.
Oh, okay.
So how would you solve this?
You would do 9 plus 14, which is
How much?
23.
Yeah, 23. And then what else?
And
then to solve for E, to get E by itself, you have to subtract 2 to both sides. You see the minus 2 that's there? And the benefit that we get from that is that gives us the power to cancel this out and leave E by itself. And then as a result, edges should be 21. So that's the reason why that's 21. All right, good. Let's go to example 2. All right, so Marcus, go ahead and read example 2, the directions.
Verify Euler's formula for each polyhedron, then draw a net for the figure and verify Euler's formula for the two-dimensional figure.
All right, good. All right, so Marcus, let's go ahead and verify it. How would you verify this one?
Well, I would first count all the faces, then the vertices,
Okay,
and then the edges.
Okay, so how many faces is there?
Got 1, 2, 3, 4, 5, 6, 7.
You're right. How many vertices?
1, 2, 3, 4, 5, 6, 10.
Yeah, because there's 5 here and 5 at the bottom, right?
Yeah.
Okay, and how many edges?
Okay, so we got 5 plus 5, that's 10 with another 5, 15.
Yeah, you're right. Okay, good. So if you're going to verify, what would you do?
Well, I'll just get the formula and plug in the amounts and see if the answers are equal. So 7
you want
plus 10 is 17, and 15 plus 2 is 17. So
it verifies, right?
Yeah.
And is this the correct net that's drawn for the figure?
Yeah.
Yeah, because it all like shows it in a 2D shape, correct? Like if you cut it all apart and laid it flat on a table, it would look just like this.
Yeah.
All right, good. Okay, so now let's go back to the next one. All right, so Maximus, go ahead and read the directions on example 3.
Describe each cross section.
All right, good. So describe A. What does A look like?
Looks like a cylinder.
No, but the cross section. Remember, the cross section is just a 2D
Oh,
shape.
circle. A
It'll be a
circle.
circle. Yeah, it'll be a circle, right? All right, Celeste, go ahead and describe B.
B, it will be a hexagon.
Let's
No.
see. You're right. You're right.
Yes?
Hexagon, because there's 6 sides. Yes. So that cross section. Okay, Marcus, what would C look like?
See, well, is that just a square? Rectangle.
Yeah, rectangle. Good. All right, so now let's move on to example 4. All right, so Maximus, read the directions on example 4.
Can a polyhedron have 19 faces, 34 edges, and 18 vertices?
Okay, is it?
Explain.
Yeah, explain. Can it?
No,
Why?
because I see no on there.
Okay, other than no, how would you prove it? How would you guarantee me the solution?
Do the formula.
Okay, so tell me the formula.
I forgot.
Well, we got faces plus vertices equals edges plus 2. So using that formula, which is the one that's written there, faces will be 19 plus 18. You get 34 plus 2, it doesn't equal. You see, I got 37, does not equal 36. So it's not possible to make this kind of polyhedron. All right, so now, Celeste, go ahead and read example 5.
Is a cone a polyhedron? Explain.
Yeah, so what do you think?
Hmm?
Marcus, what do you think?
Yeah.
No.
He's right. Cone has curved surfaces, is not a polyhedron. All right, excellent. And I think that this actually, yeah, this ends our lesson for today. Thank you, kids, for joining us. Thank you, everybody out watching this video. I hope this helps and enjoy your time. Thank you. Take care.
Yeah.
Bye.
Oh my gosh, I'm so sorry. Let me leave.